with calculations on solubility products, and I'm looking at another example which will also need extra attention. It says calcium hydroxide is sparingly soluble in water. Is sparingly soluble in water. Part A, write expression for solubility product. Write expression for solubility product of calcium hydroxide. Now, my dear friends, here I'm going to write the expression directly, hoping that you know how the equation would be written. So Kp is equal to calcium ion. This is power 1, I hope. Then the concentration of hydroxide ion squared. I hope you know where that comes from. The question wants us to write the expression and nothing else, not the equation. So don't expect anyone to write the equation herein. Part B says, if the solubility of calcium hydroxide in water at 20 degrees Celsius is 2.8 grams per liter. Remember, the concentration, the solubility we deal with in calculations must be moles per liter. So we must convert this to moles per liter. Calculate the molar concentration of Roman 1 calcium ions, Roman 2 hydroxide ions. That's our next part of the question. So the first thing we have to do before we get to these concentrations is to convert this solubility to moles per liter. And that requires us to get molar mass of calcium hydroxide, which is 40, plus oxygen here is 16 times 2, that is 32. Hydrogen is 2 times 1, which is 2. This gives us 74 grams. That's the molar mass. Now, the molar concentration of calcium hydroxide, which is moles in 1 liter, will be the mass given over the RFM, which is 74. Be convinced from your calculators that this gives you 0.0378 moles per liter. The moment you get that, you can easily get the concentration of calcium ions using the equation. You are aware that calcium hydroxide plus aqueous gives me 1 calcium ion per mole, and then 2 hydroxide ions per mole. This implies that the concentration of the calcium ion will equal to the molar concentration of calcium hydroxide. It's equal to its molar concentration, and is equal to 0.0378 molar. So we shall have answered Roman 1. Are we together?
Yes, teacher.
Then to answer Roman 2, Answer Roman 2, we shall say the molar concentration of hydroxide ions, according to the equation, is twice that of calcium ions. Or we can say is twice that of calcium hydroxide. Any of the two can give you the answer. So that is twice the value of 0. Let me see here, 0.0378. 0.0378, and gives us 0.0756 capital M. Are we together?
Yes, teacher.
Now C, is it C? This was B. C Roman 1 of my question will say calculate the solubility product of calcium hydroxide at 20 degrees Celsius and give its units. And give its units. So here you come and be convinced and say tell the examiner that Ksp is equal to, have we already written this expression somewhere? Yes. We have already written it here, we may not need to repeat it. So Ksp is equal to the concentration of calcium ions, which is 0.0378 multiplied by that of the hydroxide ion squared, which is 0.0756, but this is squared. Units here will be moles per liter. I think this is cubed, because this one is moles per liter, this is moles per liter squared. So it's the whole of moles per liter cubed. The answer here will be convinced that it's 2.16 times 10 power -4 mole cubed dm -9. Are we together?
Yes, teacher.
Perfect. Okay, now we go to the last part of this question, which is very, very disturbing. I'm calling it Roman 2. It says calculate the volume of potassium iodate that must be added to 1 liter of a saturated solution of calcium hydroxide above to precipitate calcium iodate at the same temperature. Calculate the volume of potassium iodate that must be added to 1 liter of a saturated solution of calcium hydroxide above, precipitate calcium iodate. You'll find a similar question in your question bank, but not exactly the same as this. Now we have had calcium hydroxide already. I want to see how to approach this question. We have had calcium hydroxide, it is sparingly soluble. It's giving us calcium ions and 2 hydroxide ions. To its solution, they are telling us to add potassium iodate. That's the formula of potassium iodate. It's a very soluble compound. And for it, it will strongly ionize in solution to give us potassium ions and iodate ions. So somebody is saying that when you add it, a reaction is going to occur between, this is not common ion effect, but it's a precipitation reaction, form another sparingly soluble salt. A reaction is going to occur between calcium ions and iodate ions, form another sparingly soluble salt, which is calcium iodate 5. Now they're asking us which volume of this solution must be added to precipitate this. And the question has gone again to give us the KsP. Here the KsP must be given, KsP of calcium iodate. It's given as, it must be given as 6.747 times 10 per negative 6 mole cubed dm negative 9. Actually, the concentration of this must be given. I forgot. It should be 0. Let me give it a 0.5 molar. Concentration of potassium iodate 0.5 molar. So that implies you have 0.5 molar concentration of iodate ions. That's what you should be given. So if you have that, we now need to go ahead and see the treatment we have to do to get our final answer. I've told you we already have calcium hydroxide, which is sparingly soluble. To the calcium hydroxide, somebody is adding a given concentration of potassium iodate, whose volume he doesn't know, to precipitate some calcium iodate, whose KsP is given. So if you're to do that question, I would advise you first of all write equation for solubility of calcium iodate. I advise you write this equation. You say calcium iodate is sparingly soluble, so it must give us calcium ions and 2 iodate ions. Then get a KsP expression as calcium ions into iodate ions squared. Now, according to our question, we have the KsP of calcium iodate. Am I clear?
Yes, teacher.
Given here. Then according to the same question, we have the molar concentration of the potassium iodate that was added. What do you think this concentration is going to help us get? What is it going to help us get so that we do the calculation? I think this is harder for you to interpret. It's going to help us to get the concentration of iodate ions. So we have the KsP here. We also have the concentration of the calcium ions. Which concentration of calcium ions? If I'm to take you back here, the concentration of calcium ions is coming from this side. We already have it here as 0.0378. That's why the question is telling us to solution of calcium hydroxide above. That's going to help us get the concentration of calcium ions. Then we substitute it in this expression so that we know how much iodate ions are required to precipitate calcium iodate using the concentration of calcium ions from the calcium hydroxide. So I'll substitute 6.47 here times 10 power negative, was it negative 6? Yeah, negative 6. The concentration of calcium ions from the previous question was 0.0378. 0.0378. Leave this unknown, such that your concentration of iodate ions is equal to 6.47 exponent negative 6 divided by 0.0378. Don't forget that the iodate ion was squared. So here we are getting the square root. Be convinced that your answer will be 1.31 10 power negative negative what? I think it's negative 2, capital M. That will be your answer. Are we together?
Yes, teacher.
So this implies that this is the concentration of iodate ions we need to precipitate. This is what we need to precipitate calcium iodate. But from the question of iodate ions we have is this. According to this equation and using the molar ratio, we have it that from potassium iodate, giving us potassium iodide, potassium ions and iodate ions. We have it that the concentration of iodate ions is equal to the concentration of potassium iodate and is equal to 0.5 molar. Now, if this is the concentration we need to precipitate calcium iodate, yet this is the concentration we have, we need to compare the two and their volumes to know the volume that the question requires us to calculate. Are we together? These moles are in 1,000. Then we need to get the volume in which these moles will be, so that we get the volume that will be added to the solution to precipitate the calcium iodate. So we shall say 1,000 centimeters cubed contain 0.5 moles. So which volume, x centimeters cubed, will contain 1.31 times 10 power negative 2 moles. When you work out, your x will come out as 26.2 centimeters cubed. I hope you've got the concept.
Yes, teacher.
So that is how you get the concentration of the calcium, potassium iodate. I mean the volume of potassium iodate required to precipitate that. I hope I've done enough examples. If they are not enough, you may tell me to do more. You need more about those calculations?
Yes, teacher.
Are you not yet tired?